There are a lot of challenges. The biggest one is what I call the fact that it's just a big change. Everybody hates change. I call this the layer 8 and 9 issue, you know. Above the presentation layer, you know, it's religion and politics and governance, right? And that's the same thing, and if anything, I think stands in the way of adoption of this technology, it's the concern over governance and security governance issues that masquerade as security. A lot of people say, oh, it's security, but it's, when you really pull the thread on it, it's not security, it's about control, okay? As was mentioned, different characteristics in terms of input-output. I'm a storage guy, you know, everybody always focuses on the server piece. You know, we're the guys down at the bottom of the stack that maintain the state of the network. We're not the sexy ones, you know, we're the disk drive guys, right? And people don't really think about us, but you know what? CPU is for show, I/O is for dough, baby, right? Okay? And it's the storage that determines the I/O, ultimately, okay? And as was pointed out, the characteristics on these environments are dramatically different than servers. I mean, if you were rolling out 1,000 servers, okay, that's a pretty big environment for server virtualization. But now think tens of thousands or hundreds of thousands of desktops. It's a much, much bigger problem in several areas, not only in terms of just the sheer capacity that you have to store in the network, but the I/O. And you've already heard of the different things like boot storms. I call those things herd I/O, right? Where the herd comes in at 9 o'clock and they log in. Huge read spike on the network. Or the herd sees something, you know, on the internet. Look, squirrel, and everybody goes, you know, over there. Same thing, right? So you have to be able to have a storage architecture that can manage through all that, through those different types of storms, of I/O storms. One of the biggest things I've noticed, too, is that people who've rolled out pilots and have had successful pilots roll the thing in production, and then all of a sudden it doesn't work well. You know, somehow they lost the understanding that a couple hundred desktops moving to a 10,000 seat, it's going to require some different infrastructure. You have to be prepared to invest in the infrastructure on the network side, and on the compute side, and on the storage side, everything to give you the I/O and the throughput that you're going to need as well. The interesting thing about desktop virtualization from a storage standpoint is that most of the steady state traffic is small block random I/O. Small block random I/O equal poison to the storage guys, right? Small block random I/O is the type of I/O that beats up storage arrays because caching doesn't really help you a whole lot on the right part of it. And then on top of that, you can have these big exponential spikes in small block random I/O when everybody wants to read stuff. So it's really, really important to pay attention to this. The I/O generally drives the size, not the capacity, okay? So in addition to that, you have other challenges from a storage standpoint. How do I maintain the availability? Moore's Law says every 18 months to 36 months, I'm moving new stuff in, taking old stuff out. How do I shift around the workload in my environment to allow that to happen without bringing services down to my desktops? You got to pay attention to that. That's really hard for the storage because we maintain the state, once again, of the network. Security and control, right? Have you noticed your security people are a little more schizophrenic and paranoid than they have been in the past because of this whole virtualization thing? Right? It's tough because they're now having to learn that they have to manage risk, they can't avoid it. And how do you do that in a highly virtualized environment? NetApp has come out with this NetApp and Cisco have come out with this multi-tenancy architecture to help do this, but now when you go to virtual desktops, it's kind of like that architecture on steroids, because I'm not just talking about tenants being organizations, I'm talking potentially every individual desktop being its own stovepipe, its own virtual silo. Interesting. Mass deployment. How long does it take to roll out 100,000 desktops? Okay? That's interesting. Proper data protection. I've got all this data I'm running back. All my eggs are back at the data center. How do I back it all up in a timely fashion? How do I restore it all in a timely fashion? How do I meet my DR, my recovery points objectives, so forth? All this requires careful thought and planning.